Hello everyone and a very warm welcome to our webinar. My name is Mara Beutz and I work at Carbon Minds. Thanks so much for joining us today. And before we start, I would like to point out that we will be recording the session and share it with you afterwards as well. So what can you expect in the next hour and what is really the occasion for this webinar? It is our cooperation with BASF, where we follow the common purpose of providing a comprehensive and harmonized database for product carbon footprint calculations in the chemical industry. And you will hear all about this from the Carbon Minds and the BASF perspective today. Before we jump to the great speakers and contents, I would like to give a brief introduction on Carbon Minds and what we do. And to put it very short, Carbon Minds is all about lifecycle data and guidance for a more sustainable chemical production. So we support our clients in their sustainability transition basically in 3 ways. At the core, we are a data provider. So we can give the data that you need for the assessment of your carbon footprint, so product carbon footprint or company carbon footprint, for your Scope 3 reporting or all the different environmental impact categories. Secondly, we help our clients in consulting services. We do that by assessing their environmental performance and providing the results for further decision making. So we can do environmental assessments which could range from a single product to an entire company or from a production site to supply chain analysis. And then our third division, we like to call it, is our trainings and workshops. And as you all probably know, the sustainability community is expanding quite quickly and companies are forming new LCA departments. And we help those companies through those training programs to bring them up to speed with the spirit of today. So we're going to talk a lot about chemical materials and the chemical industry, as this is just our home. But we work with all players along the entire chemical supply chain, which you can also see here at the bottom. And because you know that chemicals are used pretty much everywhere and almost all products we use have touch points to this industry. And I think you will probably also all agree that we as sustainability people are facing exciting times and we all have exciting jobs at the moment. So this is a good transition to now introduce you to the people whose also excited faces you will see in the next hour. And I'm going to start with myself. I know I'm not very polite, but my name is Mara Beutz. I'm the Global Account Manager at Carbon Minds and responsible for any information on our offerings, and I lead the process of communication and guidance on Carbon Minds products and services. And you will also be seeing Raul Mais. Raul is one of Carbon Minds' founders and CTO. He founded the company together with Arne Ketelhöhn a couple of years ago and has gained expertise in chemical engineering, life cycle analysis, and sustainability while working at Carbon Minds, but also at an institute at RWTH Aachen University, where he was leading an LCA team. And he focuses on reducing climate impacts of chemical and plastics production and is a respected figure in industry as well as science. It's great that you're here, Raul. And then last but definitely not least is our guest and partner today, Alessandro Pistillo. He is Director of Digital Strategic Projects in BASF's Corporate Development Department. And Alessandro lies at the intersection between digital and sustainability projects and is currently establishing a business ecosystem to drive standardization and transparency in greenhouse gas emissions data. So that connects really nicely to the topic here as well. And prior to his current role, he has been covering various leadership positions during his over 20-year tenure at BASF Group worldwide. He is a chemical engineer by education. So welcome, Alessandro. Thank you for being part of this webinar.
Thank you for having me here.
Thank you. All right, then let's look at what we're going to talk about today. So we have 3 agenda points, and we're going to start with talking about the big challenges in calculating the product carbon footprint for chemical and plastic products. And in the next point, we will show how BASF and Carbon Minds take on those challenges together by developing a harmonized data model. And this point shows an overview of the Carbon Minds data and how the partnership with BASF enriches that and connects to that. Then Alessandro and Raul will jump into the panel discussion to talk about why harmonized data is worth it and absolutely worth it from the Carbon Minds and BASF standpoints. And for your notice, in case you have any questions, we will talk about those at the very end of the webinar. Feel free to write them directly into the chat. And in case you already know who you want your questions answered by, feel free to write either Raul or Alessandro's name in front of that question. So without further ado, handing over to Raul.
Yeah, Mara, thank you very much for the kind introduction. I hope you can hear me well, loud and clear, and I can only highlight the point Mara told you. Today is your chance. You can ask us, let's say, anything you ever wanted to ask us. So I'm really looking forward to also a very interesting discussion in the end with Alessandro, who I really value that you take your time to be here with us. So before we go into detail about what we are going to do together with the BASF, let's start by setting the scene what the challenges of calculating product carbon footprints for chemicals and plastics actually are. And for this, we should first take a look at what's happening in the industry. And you can see various companies from Covestro, Mercedes, Apple, Lanxess, and many more to set climate targets in the industry and in their transition. While these climate targets occur in many sectors, it's relatively interesting that the chemical and plastic industry actually plays a very important role, which recently has been highlighted in an article actually published yesterday, so I can highly recommend reading it. And there, the CSO by Solvay said that the chemical industry is the mother of industry and that it serves all value chains and has thousands of suppliers. So without net zero chemicals and reduction of emissions in the chemical and plastic supply chain, there is not going to be a single sector with overall net zero emissions along the supply chain. And if we now want to understand how this supply chain in products in a very simplified example actually looks like, what the challenges are, we can take a look at a generalized product carbon footprint of a generic product. So let's assume you are producing one single product. What you can measure are your direct emissions. You can look at the chimney, measure the emissions, and they might take up a certain percentage of emissions. So that's the first part that you can directly control. The second part is your energy related emissions. So the emissions that you produce by consuming electricity, steam, natural gas, and other energy related raw materials, utilities. They add together to around 20% for several products, while they differentiate a little bit within the shares. So some have less direct emissions or even none and have higher energy related emissions. The major chunk of all chemical production and products generally come from the supply of raw materials. So if you're producing a product, up to 80% comes from the upstream supply chain. So from your suppliers and their feedstock extraction from oil, gas, coal, and so forth. This leads actually to a very immense problem because there is not enough transparency along these difficult and intertwined supply chains in the chemical industry, which also has been acknowledged by the Science Based Targets initiative in 2020, that there is a general lack in transparency for supply chain emissions. This lack now leads to three major challenges when you want to calculate your product carbon footprint. And the first major challenge is trust and consistency. If we now get data from our suppliers, we have to trust them. We have to have some sort of third-party verification by these data sets, and we have to ensure that the methodologies in the calculations by your suppliers are consistent with the calculations you are going to do for your product carbon footprint calculation. The second challenge is transparency. When we generate data for our suppliers, for our product, raw material products, then we actually want an overview of multiple regions and multiple stakeholders at the same time, because only then we can have a confident decision making and make robust decisions based on good data. The third challenge is availability. You cannot calculate your own product carbon footprint if there is no data about your raw materials available. You might have thousands of products consuming raw materials from thousands of regions, have complex supply chain, and there is simply not enough data available. And that's actually exactly what we want to address as Carbon Minds with our data. And that's where I'm going to talk a little bit more in detail about how we approach that. In general, our data needs a broad coverage, needs to be specific based on the regional options, and needs to be certified by a standardization agency or a third party. And how we actually approach these challenges in combination with our data and together with the BASF, we will be discussing in the following minutes. And for this, we have to understand first how our general approach to generate a consistent data set for the chemical industry actually works. And therefore, I would like to introduce you to a little bit broader understanding of the chemical industry and the data types you actually need to generate a consistent and harmonized product carbon footprint database for chemicals. And you need three kinds of data. The first one is you have to know where the production locations of the chemicals are and how high the volumes of these chemicals that are produced in the locations actually are. The second thing is you have to understand the technologies and the process parameters all these production locations utilize. You need the mass and energy balances, you need the energy consumption, and you need all that along the complete supply chain in various production sites. The third data is you have to understand international trade flows, particularly for Germany or European chemical producers who are heavily exporting their chemicals. Their production will influence other supply chain in various regions. So we have to understand the bilateral trade between the countries, not only within Europe, but also on a global scale. And that is exactly what we have done at Carbon Minds. And we started at a very detailed level. And in contrast to other databases, we started at a plant level assessment. For this, we collect the plant capacities and production volumes and technologies that are used for various production plants on a global scale. And in the simplified example, we're going to use plant A, B, and C producing several chemicals. So once we know the plant capacities, production volumes, and technologies, we aggregate these plants in what we call an integrated production site. Could be Ludwigshafen, could be the Houston area, could be the Rotterdam area, just making some examples. So for instance, if we have product 1 and product 2 produced by plant A for product 2 and plant B and C for product 1, we could already calculate the averaged energy consumption of plant B and plant C, and then make a production volume weighted average for product 1. However, that's not the full story, because if we have consumption, if we do an LCA or product carbon footprint, we have to consider the supply chain of all the processes. And that supply chain requires the inclusion of the raw material provision for product 1. And in our assumption, we assume that the intermediates produced within the production site rather originate from the on-site plant, like plant A. However, if there is not enough supplied from the on-site production, we then would assume that the intermediates come from the so-called national consumption mix, which now leads to the necessity to not only model one single production site, but several production sites in several regions. Now let's take country A. We have many different production sites like site A and site B, and they can now be aggregated in what we call the production mix. So this is a volume-weighted average production of one chemical in one production site. From this production mix, we now calculate the so-called consumption mix. This is production minus exports plus imports from other regions. So we did not need to do that only for all sites in one country. We did that for all sites in all countries producing one particular chemical. And since you might be interested in having one particular example of how we now generate our data sources, let me show you our unique database approach. So from the input data, we now generate our lifecycle inventory model. And from this lifecycle inventory model, we can zoom in and zoom out into different data sets and databases. So from our inventory model, we generate output data sets, which we call the CM Chemicals database. This whole workflow from input to output is continuously updated and maintained and reviewed, for instance, by the TÜV Rheinland, a German standardization agency. And based on these output datasets, we now can take a closer look into one example. And for this, we brought the example of consumption mixes for polypropylene. On this map, you can see the consumption mixes, so production plus consuming, so importing countries on a global scale. The color indicates the carbon footprint for a kilogram of polypropylene production. And you can see that there is a variance between 1 and 4 kilograms of CO2 equivalents per kilogram of polypropylene. This is due to different feedstock use, different technologies, different energy, and different trade. If we now exclude all countries that are only importing polypropylene, you can see that particularly Africa fades out because Africa only imports and consumes, but does not produce polypropylene. The difference of the carbon footprints now are only based on feedstock use, technologies, and energy supply, leading to a little bit lower range of the overall product carbon footprint between 0.9 and 3.8 as the maximum value for the product carbon footprint. Now let's take a closer look where these differences actually come from. And for this, we're going to take two countries as an example. One is China, and the other one is the United States. If we look at the production technologies in China, we find that they are mostly based on hydrocracking and on-demand propylene production. These are, for instance, technologies you know, like the fluid catalytic cracking, the naphtha, the ethane, or the atmospheric gas oil as a raw material. On demand is stuff like the dehydrogenation of propane. However, there's one unique thing about the Chinese production of polypropylene and the raw material propylene, which is the utilization of methanol within China for the production of olefins used for polypropylene. In contrast, the United States have a slightly different technology portfolio, major focused on ethane, so natural gas-based production. So there is no methanol to olefins and olefins to polypropylene production over the supply chain in China. And this leads to the major difference of product carbon footprint in the two producing regions. Because if we now take a look at the product carbon footprint per kilogram of propylene, we see that the technologies you might be used to, like the fluid catalytic cracking for propylene production, the naphtha as a resource for steam crackers, have similar values between the US and China. However, there is this exception, which is the methanol-based production in China that is used for methanol to olefins and then for the polymerization. And this is due to the fact that methanol in China is largely produced based on coal, leading to a higher product carbon footprint. From this example, you now have seen what is in the database and the insight you can get from the database. So let's have a brief look on what the BASF and Carbon Minds now aims to achieve. We have our CM Chemicals database on the left, which has a high coverage, is highly regionalized, and gives you data sets for technologies, consumption mixes, and production mixes. And what we are going to do now is use that full lifecycle inventory database and apply the BASF methodology, which in the future will be aligned with the TFS PCF guideline for the chemical industry, and make a consistent product carbon footprint database for chemicals and plastics based on this methodology. And for this, we will use 4 steps. And these 4 steps first require an alignment of methodologies. So the 2 methods are very, very similar and are almost already aligned, but we have to tweak them a little bit. And this is going to need particular be the case for the allocation principles as well as the inclusion of different life cycle stages for various products. There are going to be more during the process we are going to start now. The second thing is we will include renewable carbon technologies. This means that we're going to use mechanical and chemical recycling modeling based on scientific literature and industrial case studies, as well as carbon capture and utilization and biomass utilization technologies, and provide data sets in a consistent manner with the BASF and TFS methodology within our database. The results then going to be discussed with our partners. We're going to discuss them with various associations, industry, science, to then perform a third-party review where we extend our existing review with the ISO 14067 plus the TFS/BASF methodology. And by these 4 steps, we actually aim to address the 3 major challenges that I mentioned at the beginning. The first challenge about trust and consistency. We're going to openly provide our methodology document, which is then aligned with the BASF methodology, and additionally get a third-party certification for this new methodology document. Secondly, we're going to increase the transparency by giving the industry the option to identify reduction opportunities throughout regions and countries. You have seen the polypropylene example, and will actually be able to take a look at the complete global supply chain of various chemicals. And thirdly, our data is highly available. We have thousands of products in our database covering the complex supply chains and actually can provide thousands of regions for each chemical. So based on our data sets, chemicals and regions, plus a service to close data sets where needed, we want to really address these challenges that we have in the calculation of the product carbon footprints. And with this, we are now in the next part of our webinar, and I would like to give back to Mara and start the discussion with our partner, Alessandra.
Hello, everyone. Again, you realize there is a cut in the video, and this is because we are re-recording the discussion as we were having some technical issues in the live webinar. It's a different day, but you see the same faces, me, Raul, Alessandro, and I. So let's continue seamlessly with the discussion now. Thank you again, Raul, for introducing the Carbon Minds database and the challenges that every player in the chemical and plastic industry is currently facing. And you also mentioned that data is crucial, and with PCF data especially, it is often not clear to what extent it can be consistent and transparent, and whether one can approach the calculations with confidence and security. You have highlighted the general unavailability of data as one of the biggest challenges here. So, Alessandro, question to you. Has Raul addressed all challenges, and especially what do you currently see as the biggest driver for the calculation of PCF, and what purpose do chemical companies follow with this?
Well, first of all, product carbon footprint are a way to measure at product level the progress of any company towards decarbonization, right? And decarbonization is, in a nutshell, already now, and even more so in the next years, a license to operate for a chemical company, and more and more also a competitive differentiator. So companies with better product carbon footprint will have advantage versus other companies with perhaps not so advanced on the road to net zero in the business environment. Now, decarbonization needs transparency, as we said, and transparency on data regarding carbon emission for scope 1, 2, but also so relevant scope 3. And data without consistency are meaningless. Therefore, consistency and comparability of data is a key driver, has been a key driver in BASF approach and Together for Sustainability approach, and is the big driver behind also this collaboration between BASF and Carbon Minds.
Mm-hmm. Thanks so much. Yeah, very interesting. This also relates to the next question. We can maybe elaborate a bit further, maybe also with Raul. So how now can this harmonized methodology help in like decarbonization, this very complex chemicals industry? Why really is it needed, and what is BASF's goal in the cooperation?
Truly, I mean, comparability, as said, is the underlying motivation. And now let's try to focus on scope 3. So the emission, the GHG emission impact embedded in the raw materials. This piece of the puzzle is typically something which is not fully in the hand of any chemical manufacturer. So this is depending on data which are fully transparent, available only to value chain partner, to the suppliers of any company. Now, how to ensure that the product carbon footprint data for scope 3 is comparable and consistent? One aspect is, of course, to distribute, broadcast, propagate standards, and that's what Together for Sustainability is doing. Induce also in the supplier engagement program, supplier to provide primary product carbon footprint data calculated according to that standard. But we all see that it will be a process. It will be actually a journey, multi-year journey before every company, for every product, primary data calculated according to a standard will be truly available. Therefore, actually, the situation today and many years to come, most likely, is that a lot of a significant portion of the scope 3 will still be based on secondary data. And even for such secondary data, it is important to have consistency. So having such secondary data calculated based on data sets and methodology which is consistent and aligned is fundamental to have then measurable and fully consistent scope 1, 2, and 3 product carbon footprints. So in that context, we can see the logic of the collaboration with Carbon Minds, and in that context, we definitely see a tremendous value in data sets aligned with BASF and the together sustainability methodology.
Yeah, thanks, Alessandro. Very good points. I'm handing over to Raul and asking him her question to connect very closely to what you just said. That is more on the data-heavy side. So, Raul, what is your standpoint about primary data becoming more popular? I find this aspect very interesting, but I wonder if there's if it's a right or wrong here with primary versus secondary data. Alessandro briefly touched on this as well. So what is happening with secondary data? What's your idea?
That's a very good question. And actually, we get that asked a lot. A lot of clients and partners, associations say, okay, you're a secondary database provider, but everybody's going to use primary data in the future. And so we discuss this relatively often. And let me go through our three major challenges backwards again. And what these customers also say is in the future. That's exactly the point. Secondary data is available today. So you can use it soon in a consistent manner with the BASF/TFS methodology. The second thing is then transparency. I think that's an additional point where secondary data can combine its power with the primary data, which is we can provide product carbon footprint over a global scale. We don't need to look who am I going to provide my data sets to. So we can really show global differences, global improvements of products that, again, then have been aligned with most recent research, science, and industry association viewpoints on the transition, which then brings me to the last challenge, which is trust and consistency. I think the combination of secondary and primary data can really make LCA, life cycle assessment, and product carbon footprint trustworthy. I always like to say, when you buy an iPhone or any product, you also look in comparative portals and look at the prices. So you want to be sure that the people who give a value to you have been trustworthy. And I think here, really, the combination of the two can generate that so much needed trust. We even see that secondary databases start to increase and, let's say, include primary data sets to really base that, make a very good trustworthy secondary database. So I think these two combined will actually increase trust, and there is no either or. We have to go together, and you see that from prices in many services and in many databases already today. So I'm not afraid that the primary data will make myself or my company workless.
Quite the contrary, Raul. I can say that we are already, I mean, despite going for primary data and collecting some primary data today, we still leverage a lot secondary data, nevertheless, for validation and plausibilization purposes, right? So, and this is something that will always be a very relevant use case. Also, in a situation of abundance of primary data, which is definitely not where we are today.
Yeah. Thank you very much. I think I have one more question that is very interesting for me as well, because I will be the person talking to people interested in this new harmonized database. Raul, maybe to you as well again. When will the data roughly be available, and how can you get it?
That's a very good question. And let me come back to the steps we are now proceeding. So what we will be doing is we're going to start with methodological alignments like allocation and some life cycle stages. So we're going to have a lot of discussion also with the BASF colleagues about these kind of methodological issues, and then come up with a joint revision of the methodology we need to apply in our secondary database. That's the first step. But we also need to discuss that with our peers. So the time frame has some uncertainties in it with regard to when will this actually be available. So if I would have to guess, yeah, this would be something between 4 and 6 months where we're going to have a first version of our database in alignment with the BASF/TFS methodology available. One important point I want to make, we want to get that new methodology reviewed by a third party. That is, it is aligned with all the standards, still aligned with the ISO for LCA, for product carbon footprint. This might take a little bit longer because there are a lot of people actually currently requesting these kind of reviews from the third parties. So this is something more uncertain when this will be ready.
All right. Yeah, but already a good time range for anyone who's interested. Okay, do you have any open topics you want to touch on at the moment for this discussion round?
Maybe just let me thank Alessandro that you have been available for us again
Yes.
to discuss these topics. I think you can see really the good collaboration and the good teamwork and team effort here. So thank you again very much for your participation and the discussion points.
Thank you, Raul. Thank you, Mara. It was a pleasure. And hopefully this time the connection was much better than last week.
It was way better. Also, many thanks from my side for the great exchange and the availability to wrap up this discussion and really make the topics clear and transfer them to the people. Also, thank you for everyone watching the live webinar and this recording here today. Feel free to reach out directly to us at Carbon Minds or to Alessandro in case you have any questions on this topic. And yeah, wishing everyone a great week and talk soon. Bye-bye.
Bye-bye.
Bye-bye.